Welcome everyone to another session Data with Nikk the Greek. And today we're going to continue our journey with Delta Lake for our modern Lakehouse. In the last episode, we got started doing overrides and appends of data frames in Spark, and we pretty much realized it behaves similar to writing parquet tables. So if you missed this session, you're going to find here up a link to check out how to get started with Delta Lake. But today we're gonna do something which is not possible with those immutable parquet tables, doing deletes and updates. And that's where you see one of the benefits of Delta Lake already in action. So with that said, let's get started. Let's jump into the code and I'm gonna show you how to do deletes and updates using Delta Lake in Spark. All right, so as always, we are starting generating our Spark session and import two lines for Delta are those, as explained in the previous episode, so that we can use Delta together with Spark. So what we are starting to do first is writing data in our path Delta, which is indeed data Delta test. And what we do in the first step is we generate using Spark range a data frame with a column ID gonna be at the end 1 to 5, so the 6 is excluded, and we add a static column name with a value Nikk to it, and then basically do an override into our Delta table. And if you're reading it, we're gonna come up with the following outcome. So this is our data frame. 1, 2, 3, 4, 5, Nikk. And I also show here the detail in the history. So we can see now we wrote a Delta table which has currently one file, which has a size of 773 megabytes. And we also see the reader and writer version here, which is not relevant. And in the history, see exactly the same. So we wrote one file in this operation, and the number of output rows is 5, which we're also able to see in the data frame, and we see the size in bytes total 773 is the same. And if you're listing also the parquet files which we have currently one parquet file as already seen in the details. So now we're doing the same thing. We just append a data frame 6 to 10, so 11 is excluded, and we add a name Marco. So let's do this, and then we are extracting the same information here again. So now we can see we have the another 5 rows written with Marco as expected. We now see in the details that we have 2 files with a total size of 1551 bytes. And in the history, we now see we had a second file written, also with 5 rows, with 778 bytes in this case. So, and here you see like how important it is to use those details in history to observe what happens in your Delta table. And also when we list the files using OS, we can see that we have 2 files written as already seen in the history and in the Delta details. But now we're gonna come to the fun path. So let's imagine now we want to delete the row with ID number 1. So just to see the data frame here we have the ID number 1, and this row is the one we want to delete. And generally you have like multiple options. So you can use an SQL formatted string, which I'm doing here and usually prefer. You can use the SQL functions f.call, or you can also use Spark. So in this case, I'm not using a catalog table, so that's why I'm doing delta.path delta. Otherwise, you can also just replace this with a catalog table name. So, and if I'm executing that, let's see what happens. I can see, okay, the result is that the row 1 has been deleted. So that's exactly what we wanted. Let's also list here what happens. So now we have 3 files, but in the details, we can see that 2 files are only active. So we have in the background, we have 3 files, but that's not what Delta is currently using. So in this case, what seems to have happened, that's something we have to investigate in our history is that we had an operation, delete, with a predicate ID equals 1. And then in the operation matrix, we see what happened. So we removed one file from the current Delta version, and this file had 773 bytes. So remember, this was the first file written here, 773 bytes. So the first file was ID 1 to 5, so that's why this has been removed. And now 4 rows of those 5 rows in the first file. So here are the 5 rows, here are the 4 rows. So let's ignore the deletion vectors. Have been added to a new Parquet file. So that's a third file which we actually see with 767 bytes. So now basically we reduced our size by 6 bytes. So 773, and here we have 767, and that's also how we come up with 1545. So if you sum up 778 and 767, you're gonna come up to this number. And that's really important to see because a Parquet table is still immutable. What Delta is doing in the background pretty much is, very simplified said, it ignores the old Parquet table and rewrites the other 4 rows into a third Parquet table, which is gonna be the active one now. And that's really important to know because if you have like a Parquet table in the background from Delta, which has a lot of rows, it's well, can be very inefficient if you just delete one row. And that's where also feature deletion vectors, which we already see here in the meta information comes in place. But that's a story for another session. So it's just important to understand, okay, how to execute a delete in Delta right now and what Delta is doing in the background roughly to just understand. So, and similarly, the behavior is when we are doing an update. So in this case, we take ID7, so this is going to be the second initial file which we wrote, and we're doing an update. So we need to define a condition. So in this case, I want wherever ID is 7 to replace the name to Strahinja. And again, we have 3 options to do it. So we can either use the SQL format string, which I used here, or we can use Spark functions f.call and f.lit, or we can also use only SQL again. So let's execute it and see what happened here. So let's start with the end. So we see another Parquet file as expected at the time has been written. We also see again, we still have 2 files active. So that means we have to check again, okay, what happened here. So one file has been removed with 778 bytes. And I mean, in this case, we exactly know which one it is. It was a second file written with the data ranging from 6 to 10. And when we're looking further down, again, 4 rows have been copied here. So, because only 1 row has been changed. And then we see 1 added file and number of updated rows is 1. So that's exactly what we expected. And now the file is 787 bytes compared to 778 bytes. So if you now let this here sum up 787 and 767, you're gonna come up to the size which we have up here. And with that, this was already everything about deletes and updates. So it's pretty simple, or you can do it in Delta. We're gonna talk about some efficiency topics, concrete deletion vectors in the next episode. But that's it for now. So remember that Delta is rewriting the data, so it just can't change a row in a Parquet table. That's the important message today. And that you have different options to do deletes and updates using Delta. And with that, thanks a lot. Stay tuned for the next episode and see you soon.